Hello everyone, this is a lecture from September 6th. I forgot to publish it, so I'm actually recording it again. Alright, so we will talk about classes and objects. This is chapter 4, and I think it's time to start doing that, and we will return to JavaFX later. So we will be implementing our classes and creating our classes from scratch. Class, just a reminder, a class is a blueprint of an object, and an object is an instance of a class. So that's like a house from a blueprint. An object has a state and attributes. State consisting of attributes and methods. So a state, for example, if your object is a bot character in a video game, your state would be all the stats and characteristics of this bot. So the bot is in charge of knowing things about itself. And the methods would be the way this bot interacts with the world outside of itself. So methods are otherwise known as behaviors, more generally known as behaviors, and okay, so let's talk about the class. The class is that contains the main, is the starting point of a program, and that's where that's what Java looks for to begin running the code. So every object has a state and a behavior. So we will need to declare data and declare methods, which means describe how they work, and well, first declare, then describe how they work, and the attributes do describe the state of the object, and the methods, or otherwise known as functions, define the behavior of these objects. So let's quickly look at this example. Just a moment, we're good. Employee is a class. It has attributes, name, department, title, and salary, and it has setters. Also, setters where these corresponding attributes are set. And we do remember that we don't want to directly set them by directly referencing the attributes. We want to have special methods for example, setting the department, just to avoid the situation that the person who is using the class or calling the class may make a department something that does not exist by mistake. And so we are encapsulating and protecting our attributes in particular. The method setDepartment would know to check against a list of constants, which is all possible departments in this company, and if it doesn't match any of those departments that actually exist, it would not update. So there are some public methods that can compute wages, compute bonus, compute taxes. Typically, they are public, which means that they are visible from outside of the class and outside of the package. We will talk about public, private, and methods a little later. Alright, before we go on to creating our own methods, let's see how it works for the string class. Sorry, for our own classes. Let's see how it works for the string class. So string, we're declaring an instance of the string method, of the string class, and the name is test, and we just use a shortcut where we just supply a value because our string class is a standard class that has some nice behaviors. So we don't need to do new string in parentheses hello, but we can. And finally, we do system out println test. What happens under the hood when we call print? We call in the object test, there is a toString method which is being called, and it supplies a string to be printed. In every class, there is a toString method, and by default, it would just show the 16 hexadecimal address of the object itself. And we are to update that and to change that to what kind of string we want to see when we do println. So this is how we can override really the string method. So public string to string. So this string, this is a reference to the output, what is the format of the output that we want to return. And public means it's visible outside of the class, and outside of the class and the package actually. And we are defining a new string, which is result, and integer.toString face value. What does this do? There is apparently a variable face value somewhere else declared in the class, and the class integer with the method toString is going to convert it to actual string. Alright, so this is a public class die. It's about rolling a dice, not what you thought about. And we are going to briefly talk about it. So I'm gonna make an example a little later by myself, but this is very useful because right off the bat there is private final int max equals 6. So the word final, the keyword final, means it's a constant. It's not going to be changed anywhere in the specific object created from this class. Private means that the variable is only visible inside the class, which is how we like it. And if you don't remember the reasons, I will talk about them more later. So int means that it's an integer. Similarly, private int, this is actually a variable, private variable. It's visible only for the class. It will be supplied during the initialization process that is creating the constructor. So public die creates by default face value equals to 1. And then we can change it later using one of those setter methods. And okay, that's all for this page. And oops. Just to remind you, the scope of the data is the area in a program in which the area of the data is referenced. So data is declared on the class level and can be referenced by all methods in that class. And data can be declared in a method that can, and thus can be only used in that method. That is local data. So we can declare data in the main method. For example, this is a declaration of data. It will be visible only in the main method. And this is a declaration of inside the print function, print dog function. So this variable is now local and is declared inside this print dog method, and hence this value of dog will only be visible inside this function. All right. So this is a reminder about instance data. So die1 and die2 will be the dice created, for example, in our method, and they will be supplied with actual variable face value, in one case 5, in another case 2, And since face value is an integer primitive type, it actually holds the value as opposite to holding a memory address to the class. All right, before we go on to examples, let's familiarize ourselves with Unified Modeling Language. So it shows relationship between the classes. So rolling dice is a class. It contains the main. And since it contains the main, it returns nothing, in other words, void. And so you remember the declaration for the main method, public static void main. So the word void in that declaration refers to the output. So the keyword just before the name of the method is the output that this method is supposed to return. Okay, so every box creates the name of the class. It creates attributes. In case of the rolling dice, there are no attributes. And it creates a main method. It has a in general, they have methods. Let's look at the die class. It has one variable, face value, int. Remember that we did not declare the constant in here. Notice that there was a constant, but we don't even mention the constant here. And we have 5 methods. Row returns int, set face value, takes an argument value and returns void. It's a setter, so it just changes the internal value of the variable. And get face value returns an integer, which is the face value. And finally, toString returns a string. And neither of the last two actually take any arguments. Alright, so before we talk about encapsulation, maybe it's a good idea to just create a new class from scratch. So we are creating Java class, calling it main. And just to be cool, I'm going to write right away how this class is supposed to work. So I'm supposed to create a dog instance, Sparky, named Sparky. Which is equal to new dog, and I will supply the name and the age, 3 years old. And just to do something with Sparky, I'm gonna do system.out.println, and my output will be Sparky dot get name plus just a blank space in between, and plus Sparky dot get age. So none of this works because I did not create the dog class yet. You don't really expect this to work. I should have a semicolon. And time to do that. Actually, let's create new class, new Java class, and I'm going to call it dog. Alright, so public class dog, and here I'm creating a pair of private variables, private string, name, private int age. So we declared our variables, and now we need to do the constructor. So the constructor should have is a method that has the same name as the class method and no keywords in front of it. So dog, and do string name and int int age. This dot name equals name, and this dot age equals age. So this is a constructor, and the analogy in Python is, let me just say it. In Python, the constructor is double underscore init, double underscore name age. So that would be, whoa, I said in Python and I started to comment in Python. Alright, so in constructor, that's what in Python, that's what the constructor is called, init. And it is actually initializing the instance of the class. Now, a little bit of a background here. All classes are children of the Java class. So what we're doing here, we're really overwriting the existing constructor, which has no parameters. And that's something you need to be aware of. So for a class, there is a constructor, and we are overwriting it. Okay, and then we have to create all the getters and setters. So this is a public method, public set name. It will be void, and by the way, IntelliJ is nice enough to remind me to put void. So set name, this will be new name, and I will just do this dot name equals name. And I have to declare the type of name string. Okay. And very similarly, I can do all the setters and getters. So maybe I'll write the getter, or yeah, we need getters. Public string get name. No argument there, so we are going to just say return. Fully we have to say this dot name, but we don't have to do this in Java, so we just say name, and it knows that I'm referencing this variable. So there is one related problem. Let's see. So get name should be what is one related problem? Let's see the errors just for fun. Okay, println system out println for some reason cannot be resolved. Okay, I actually know what's going on here. Do you? What's going on? I forgot to do public static void main. In other words, psvm, and this code with the new producing the instances and trying to print actually belongs in there. Alright, so this is resolved. The only one that I don't have currently is getAge. So we need to do getAge. Now, full disclosure, the constructor as well as standard getters and setters, they are necessary for having a workable class or adequate class. And they are kind of trivial code, and I do recommend writing them by hand to spend some time understanding and processing these keywords such as public and void and getting them right. But if you press code and press generate, you can generate a constructor. You already have a constructor. I just wrote it by hand, but that's how you do it. I need a getter for the age. So usually there is a bunch of options here, and you actually have a choice which getters and setters you want and which maybe you don't want. So I do want them. So let me do the getter. You can do getters and setters together, or you can do them one by one. Just to finish with all the getters and setters, I'm going to put another setter in there. So the only missing setter is for age. So we have full outfit of getters and setters. By the way, the default behavior of IntelliJ, it would fold all the trivial code, which is this part of the constructor, as well as getters and setters. Alright, so it's time to run our main and see that it works. It's gonna take a little bit of time when I'm also running a video. My computer takes its time. It's just a humble office laptop, so... Okay, Sparky was the name. Maybe to distinguish Sparky, the name, from the Sparky, the name of the class instance, I need to capitalize and rerun. In any case, we created a little bit of a class, a dog class. It's not a very amazing class so far. It just does some trivial things for us. Okay, now the name is capitalized. And we want to go back to it and discuss certain things, so I'm going to first discuss encapsulation. So you want your variables in the class, in the instance of the class, to be protected. That is, you want your attributes to be private, not public. The reason is, if you don't do that, for example, somebody can enter negative age for the dog, and you don't want that. Or you might want to check the name if it contains some like foul language before you let the dog to be created. And all of that can be done in getAge, for example. In setAge. Or it can be done while making a constructor, even better still, if you want your constructor to produce output. So maybe I'm gonna even do that. I'm not gonna check anything about the name. I'm going to say if age greater than 0. I need to enclose this condition in parentheses. I'm gonna say that age is that, and else I can set this age to be 0, or the way actually people like it, if there is an incorrect input and you still have to set the variable of the age, make it -1. Typically -1 means incorrect input unless otherwise makes sense. So for age, if I put -1, that will be incorrect input. So that's one way to control it. Or maybe you want to do now. No, not like that. So I want to okay. For some reason it doesn't let me do a null value, probably because it's an integer. So usually people just put -1 in that age. So that kind of this is a way to handle a potential error in the age. And okay, so far so good, and we are going to add a slightly less trivial method to this class. So public public return string, we're returning string, and I'll say get human age, or just human age. And what will this do is just print out age times 7. So let's assume that the age of the dog times 7 is equivalent to the human age. Okay. Oh yes, so now it has to return an int, since it was an integer. So something like that, that will be a little less, probably less expected of a method. And while we are at it, we can immediately create one more method, toString. So toString is a standard method. We want to override it, so it returns a string, and the name is toString. What we want to do with it, we want to specify what this method, what happens when we call print on the dog object. Okay, so toString will be return. This is a dog named name. Since we are inside the class, we are allowed to reference this .name as just name, plus the dog is age years old. Okay. I think this is a good printing statement, and we can go back to the main and actually test it. Let's test it, test everything that we did. First of all, I want to keep this printing statement, and second, I want system.out.println, and I want to just print Sparky to get all the possible information about it, whatever the print statement is supposed to do. And then I want to copy paste this. After I do Sparky dot rename, oh sorry, Sparky dot set name, and I'm gonna call it Woofy. And again, print all the information. Alright, so Sparky, age 3, created here and printed on the next line. This is a typo here, named Sparky, the dog is 3 years old, and then we changed the name and printed it out. So this is the basic behaviors of the class main, of the class dog, and that's how we write classes. And this is most of the stuff that is much of the stuff that is covered in this chapter. What else do we need? Okay, so I talked about the encapsulation. A class should describe the variables and should describe the methods, and the variables should not be accessible directly, rather they have to be available through the methods. So you may be able to change them if the designer wants you to, but only through the method, which will check whether your input is correct and it's actually feasible to or reasonable to change the value of the class attribute. All right, so we want to be switching between two viewpoints on the objects. Internal, that is how the object works, the inner workings of the object, sort of the back end of the object, the variables and the methods. And external, the services that the object provides and how it interacts with the rest of the system. We should not be letting the client to change the data directly, but rather with the methods. So going back to my class, if I don't want the person who is using the class to change the name of the dog for whatever reason, I can just simply not allow the set name. That's one way to do that. If I don't want the user to change the set age, or I want to do it in a certain other way, because as time goes by, the age changes every year by 1, and that's probably the only thing I want to do with set. Instead of set age, I'll say add age, and it will not do anything but increase the age by 1. So plus equals 1. Okay, so we can make a dog older by 1 if we need to update our records, but we cannot randomly change age of existing dog by whatever amount. Alright, so those are some reasonable things to do or not do. And methods is how these objects made from this dog class will interact with the rest of the world. There is a special method, constructor, which is in charge of actually creating this object every time. Every time the object is called, like Sparky equals new dog and such, with all the arguments, actually triggers the constructor, and the object is created, and then get age, add age, and so on are the ways that get name, human age are the ways that these objects will interact with the world, with other objects. So of course, the additional advantage of that is that the client does not need to know how the method or the data works, as long as the method names stay the same. Methods could be changing, or like the class could be using some database and change the database and can be updated in some way. But as long as the method names and signatures stay the same, the client doesn't need to know that something changed. Might want to know, but doesn't have to. Yes, so client should see methods, but does not need to see code logic. And the other way around, the person who is developing a class is definitely doing it for somebody, but does not need to know how exactly this object will be used. So visibility modifier, modifiers public, which we used quite a bit, private, that we used quite a bit, and protected. Now, final describes constants, and public, as I was saying, were visible anywhere. You don't want to make public variables because that violates the idea of encapsulation. And instance variables should not be public, they should be private. Okay, so private can be referenced only within the class. Protected can be referenced from the same package. Alright, so this is a quick diagram. Public variables violate encapsulation. We don't want that. Private variables are good, our way to enforce encapsulation. Public methods are good because they provide the way for the rest of the world to interact with this object. And for the user to interact with this object, or for the rest of the program to interact with this object. And private methods are helper methods, or some methods in charge of making something work efficiently. And for example, some sort of fast sorting method can be a private method that is called only when the list is very long, say above 1,000 elements, because this private method can have overhead of initializing it or initializing variables for it, and it's not worth calling it for short lists, but for long lists there may be a point of doing that. So there is definitely a place for private methods inside the class, and they do get used. So accessors and mutators, if you studied well Python, you remember these two words. Accessors are getters, they bring the value, and mutators are setters. They set to a new value. So getters typically don't have any arguments, so they just get the variable x and return it. So it's like public for data type for variable x, kind of declaration. And setters do have a variable. Okay. So setters, they have, like, if you want to set an integer x, you will have in parentheses int x. And you will not need to return anything, so you will have void in declaration. You will have reserved word void. So yeah, known as getter and setter methods, and it is about the state of the it updates or retrieves information. Alright, so we need to talk a little bit about a method and about constructors as well. Again, constructor really is a special type of method. It has the same name as your class. You don't need any modifiers in it. And you want to construct your instance of the class, so it runs as soon as I call new on this dog with name Sparky and age. This is when the new object is created, and the variable Sparky actually references this object. Okay. Now methods can be static methods can be declared, and I will show you that in a little bit. So this is a nice little diagram that you might want to study. We have a main. In the main, somewhere we created an object, obj, and now in the main we call object.doIt. DoIt is a public method or protected method, and it's actually executing, and it's calling on a help me method, which is a private method. So private method exists inside the class, and it helps the doIt method. And you can see from the scheme how it runs and the order in which it actually works. All right. Alright, so method header in detail. This is the method name. Before the name, you declare the return type. Again, for the constructor, you don't declare return type, not even void. If you don't return anything from your method, you say void. And in parentheses, you have parameter list, so strong typing, there is a type, and type. Actually, we pass a string, which is a class, as a parameter for this method. And that's how it can work. So this is the body of this method. Calc is supposed to take two numbers, add them up, and then take the string and find the character at position supplied by the sum. So if sum was 3 after this calculation, it will return a character at index 3, which is the 4th character from the beginning. So it returns result, which is a char. That's why there is a char over here. Alright, so that's how you declare methods, and it's best if we actually do that in example. So I want a new project, and the new project will be method methods Java. I need to create a main. We need to say that it is actually a main. And I want to have a couple of integers here, x equals 10. Just hard code them for the sake of saving time. And another integer, y equals 15. And finally, I want to create a static method. So why it's static a little later. So let's have it static int. It will return an int, and the method will be called sum. And it will take two integers, a and another integer, b, two formal variables, and it will return a plus b. And in the main, we're going to print the output of this method. So we are going to call sum of x and y. Why x and y? Because those are the actual variables with values, and we call sum static method on them. Now, why does it have to be static? Static means that you don't need to you can do it public static or just static. That does not matter for us right now. But the thing is that in this class main, we do not need to initialize anything to call on the static function. We don't need to initialize an instance of capital main. all we need is we need to run this function. So this is a static function. It does not want to, and this is a static function. They don't want to depend on a particular object that would be initialized, and they can run without being initialized. If you remember the math class is made of static functions that just take, for example, numbers and add them, or whatever they do in the math class, square root and such. All right, let's run. Make sure that it runs fine. Still building. Parse in Java. All right, so it did compute the sum and printed it out. So I called my static method from inside the main. And so you can create your functions, just like you did in Python functions, like def. This is an analog of def f of ab, and then colon, and then the description of a function, which is really return a plus b. And I think that's about everything I wanted to say with regards to the methods. Yeah, since this is a compiled language, it's important to remember that we can declare methods after, for example, we can declare them after the call in the main, after we call them in the main, because the whole thing is going to be compiled first. Yeah, so when the method is called, actual parameters are copied into the formal parameters. So object.calc, this was not a static method, by the way, the calc wasn't a static method because we had to initialize the actual object for it, apparently. But 25 was supplied to num1 into the formal variable num1. Count is supplied into num2 variable. Count presumably was defined before, otherwise it will throw an error. And finally there is a hello, which is supplied into the message. And we will play with the account class next time. And there is something that is called a default constructor. So constructors don't have any return type, and we really are overwriting the existing constructor that has no parameters. And that's about all you need to know about the constructors. Let us stop here, and we will do the JavaFX later. So that is something that we will need. I think we will need it for your homework, next homework.